Before entering into actual video, let me just give you an introduction about us. We are Endurance Engineering Academy. We offer online video course for GATE exam preparation. Okay, and also we offer full video course for GATE XC. Okay, so if you are planning for writing XC, you can visit our website for our full video course. This is our website link, and you can see this link in the description also. And you can call us at this number, or you can WhatsApp us. We will be getting back to you with the required if you have any queries, or else you can message your queries to our mail ID support at endurancengacademy.in. Okay, let us proceed for the video. And this video is an extract from our full video course. Let us deal with different types of basic ideal flows. So basic ideal flows means the fluid is going to be incompressible, at the same time viscosity is zero. And in all this different flows, I'm going to define both stream function and also velocity potential function, that is both psi and phi, which clearly indicates that it has to be incompressible and irrotational also. So overall three conditions are there: viscosity 0, incompressible and irrotational. Okay, these are some basic conditions. Now under this condition, the first flow which I am going to discuss is rectilinear flow or uniform flow, or in sometimes it is also called as free stream. Okay, free stream flow. We already know what is meant by uniform flow, right? It's nothing but flow where the velocity or any property, in this case we will talk about velocity only, flow where the velocity doesn't change with respect to space. Okay, so here also similar type of thing only. Here there are three different cases. First case I am going to take where velocity in horizontal direction is not changing and velocity in vertical direction is 0. So velocity along x direction, okay, is constant. So uniform flow with a constant velocity u along x direction, but along v direction it is 0. Okay, so if I take v as 0 and u as constant, this is how generally the flow will look, right? The fluid which is flowing, which has to be parallel to x-axis. Okay, let it be. Now generally we know that u is going to be equal to, we are going to form an equation by using stream function and also from the velocity potential function. We know u is equal to dou psi by dou y, and v is equal to minus dou psi by dou x. Now v is 0 because there is no vertical component of velocity, only horizontal component of velocity is there. So v is 0. So if v is 0, which implies dou psi by dou x is 0. What does it mean dou psi by dou x 0 indicates? Dou psi by dou x 0 means psi is not a function of x, right? If I differentiate psi with respect to x, it's becoming 0, which clearly indicates psi is not a function of x. So psi is a function of y alone. Psi is a function of y alone. So this equation, okay, I can write it as d psi by dy, which is equal to u. I already know that u is constant. Okay, so if I integrate it, what I will get? If I integrate it, psi will be equal to u into y plus some integrating constant c. Am I right? Very simple. Why I am writing d psi by dy? Because psi is a function of y alone. Psi is not a function of x, because dou psi by dou x becomes 0. Okay, so by integrating it will become u into y plus some constant. So this is the equation of stream function. Okay, so let me write it here, because finally let me plot it in the graph so that it will be useful. Psi is equal to uy plus c. Now similarly, if you take what is that, velocity potential function, that's going to be u is equal to minus dou phi by dou x, and v is equal to minus dou phi by dou y. Okay, we are taking only for two-dimensional case. Now velocity becomes 0. Okay, velocity becomes 0, so this goes to 0. Okay, which clearly indicates phi is not a function of y, because partial differentiation of phi with respect to y is becoming 0, which indicates that phi is not at all a function of y. So if it's not a function of y, then phi is function of u alone. So instead of using partial derivative, I can use normal derivative. When I use partial derivative, I will use partial derivative only if something is function of more than one. Okay, if something is function of more than one variable. But in this case, u is function of phi is function of u alone, so there is no need for using partial derivative. So simply u will be equal to minus d psi by dx. See, instead of writing this minus here, I will write minus here. Okay, now integrate it. If I integrate it, pi will be equal to minus ux plus some constant of integration c. Okay, this is our second equation, which is corresponding to velocity potential function. So phi is equal to minus ux plus c. Okay, let me highlight it. Now let us draw the diagram. So now to get a constant stream function line, which is nothing but a streamline, so where psi will be constant. Okay, so now see this equation, the first equation. Psi is constant. Already this is one constant. U is also constant because I am taking uniform flow with a constant velocity u along x direction. U is also constant, c is also constant, psi is also constant, so which clearly indicates y will be constant. Okay, so how does constant stream function line or streamline looks? Simple. If I plot it, this is y, this is x. Y is equal to constant is the equation of our constant stream function line. So y is equal to constant means what type of lines I will get? I will get a horizontal line, right? Y is equal to constant, which indicates line something like this. Okay, so let us take this is psi 1, psi 1, psi 2, psi 3, psi 4, psi 5. Okay, so horizontal lines indicates y is constant. Now, what about this case? If I take the second equation, what's going to happen in the second equation? If it is equipotential line, okay, equipotential line means phi is constant. If phi is constant, already one constant is there. U is also constant because it is uniform flow with a constant velocity, so x will also become constant. So the equation, or how does equipotential line will look? Equipotential line will be which is similar to x is equal to constant. X is equal to constant means it's just a vertical line, so it looks something like this. Okay, so this is phi 1, phi 2, phi 3, phi 4, phi 5, etc. Okay, so this is our flow field, and we know that these meshes combinedly flow net. Okay, and one small thing to note here, when I drawn stream function, okay, when I drawn stream function or constant stream function line, I used arrow mark. Okay, but for equipotential line I didn't use the arrow mark. Why? Because generally the stream function or the stream lines will indicate the direction of fluid flow. Okay, which direction the fluid flows, because we know the streamline is nothing but what? Streamline is a imaginary line such that if I draw a tangent to it, it represents its velocity vector. So just think about this case. If I draw a tangent at this point, okay, if I draw a tangent at this point, how does it look? Horizontal, representing its velocity vector. If I draw a tangent at this point, again it's horizontal, representing its velocity. Again, if I draw a tangent, horizontal, representing its velocity. So that is why I am using arrow mark to specifically mention that stream function line, constant stream function line or streamline, and I am not using arrow mark for equipotential line. Okay, and we already know that equipotential line and streamlines will be perpendicular to each other. So next case in uniform flow is uniform flow where the velocity in y direction is constant and obviously x direction velocity is 0. Okay, so v is constant, u is 0. Okay, so and this is how the flow will look. Okay, flow will look in this direction vertically. And again, now if I go back to the equation, u is equal to dou psi by dou y and v is equal to minus dou psi by dou x. In this case, this will be 0, okay, because u is 0, right? Since u is 0, dou psi by dou y becomes 0, which implies psi is not a function of y, okay? So psi is a function of, psi is not a function of y, psi is a function of only x. So as psi is a function of only x, why it is not a function of y? Because dou psi by dou y, right, with respect to y it is not varying, so it's not a function of y. So it's a function of only x, so instead of this I can write it like minus d psi by dx. Okay, instead of using dou I can use d, which is equal to v. Okay, I will bring this minus this side. Now integrate it. V is a constant, so if I integrate it, psi will be equal to minus vx plus constant. Okay, this is one equation. Let me write it. I will write it at the end. Okay, so let it be. Yeah. Now what about equipotential function? U is equal to minus dou psi by dou x, and v is equal to minus dou psi by dou phi by dou y, and u is 0. So if u becomes 0, which implies phi is not a function of x, okay, because phi is not varying with x. First derivative of phi with respect to x is becoming 0, so phi is not a function of x. So phi is not a function of x means here I can write it like d phi by dy is equal to minus v. If I integrate it, phi will be equal to minus vy plus constant. Okay, these are the two equations. This is psi equation, phi equation. Let us plot now. So now the first thing from this equation, what I can say, it's suppose if I am taking constant stream function line, okay, constant stream function line or streamline, psi is constant. Already this is also constant. We know that v is also constant because this is the case 2 where velocity is constant along y direction. So psi constant, v constant, c constant, so I can say that x is constant. So how does my constant stream function line looks? X is equal to constant. X equal to constant means it is x equal to constant means it is a vertical line. So it looks something like this. And how does do I need to mark arrow mark? Do I need to put arrow mark? Yes, of course, because it is a stream function line, right? And it's going to be psi 1, psi 2, psi 3, psi 4, psi 5, etc. Now, it's pretty obvious. You can directly say that how velocity potential function line will look also, but we can get it from the equation also. So if I use this equation and if I put velocity potential function as constant, that is phi is constant, this is constant, already v is constant, this is also some integrating constant, so y will be equal to constant. Okay, so this indicates equipotential line will look like y is equal to constant. Okay, equation of equipotential line is y is equal to constant. Y is equal to constant means it is a horizontal line, right? So it looks something like this, and you don't use the arrow mark here. Okay, so this is phi 1, phi 2, phi 3, phi 4, etc. Okay, and it's pretty simple that it has, what is that? It's perpendicular. Okay, now there are some places where they will ask you to represent this equation in terms of polar coordinate. If they ask you to represent, what you will do? Simple. If I take some point here, okay, some point here, it's my position vector. Okay, corresponding to this point, this distance is x. This is some basics from your mathematics again. Okay, this is x, and this distance is y, and if I connect this two point like this, okay, so this is my r. Okay, so OP is my position vector, right? And if I take angle between this OP, that is position vector, and x-axis as theta, the more general convention, okay, so if I take angle between the position vector and x-axis as theta, then I can write x is equal to r cos theta and y is equal to or sine theta. Okay, so same equation. Okay, if they ask you in polar coordinate, what you will do? Replace x with r cos theta, replace y with or sine theta. Similarly, whatever we did for the first case also, there also we got two equations like this. You replace x with or cos theta, y with or sine theta. So let me write it here in polar coordinates. For case 2, how does it looks? Psi is equal to minus v is a constant, r cos theta plus constant. Most of the cases, this constant will be taken as 0, the integrating constant, most of the cases, okay? But some cases they might give some value, but most of the times we have to take it as 0. Okay, phi will be equal to minus v into y is what? R sine theta, okay, plus c. This theta is angle between position vector and x-axis. Why I am specifically mentioning this now, you will understand in the next case. So the last case of our first type of flow, uniform flow, is uniform flow with a constant velocity, some constant velocity capital V along some direction. Okay, so along some direction, it is not horizontal direction, it's not vertical direction, it is along some direction, and that is inclined at an angle of alpha from horizontal or alpha from x-axis. So from x-axis, it's inclined at an angle alpha. Okay, so and the velocity remains constant. You could see that this is our flow direction, this is our velocity direction. Okay, and it is inclined at alpha from horizontal, and the velocity which I am going to take, the constant velocity is v, and if I resolve this v in horizontal direction, it is v cos alpha, which is going to be u, which I am going to take it as u, and if I resolve this v in vertical direction, that is vertical component of this v will be small v, which is equal to v sine alpha, and overall you could write it like this, right? V vector is equal to u I cap plus v j cap. This is most generalized case. Okay, the constant velocity was at some angle alpha from horizontal. Okay, now how to find out how does the constant stream function line looks and how does the equipotential line looks? Simple, take the equation. Okay, so here v is also not 0, u is also not 0. So let us do the integration of this partial differential equation. So if I do this, if I do the integration of this, phi will be equal to u into y plus, generally when I am integrating it, when I am integrating normal differentiation, I will get some integrating constant. But in this case, it's a partial differentiation with respect to y. If I differentiate something partially with y, x will also be taken as constant, am I right? If I differentiate something partially with y, all the other variables will also be taken as constant. In this case, the another variable which is available here is x. So if I differentiate this function psi with respect to y partially, then x is also taken as constant. So the integration constant which I am going to get may be a function of x also. Okay, maybe a function of x also, or maybe a general constant. So please understand that why I am writing this f of x here. Why I am writing f of x here? Because it's a partial derivative, partial differential equation. And if I differentiate partial differential equation, first of all you need to understand this. Partial differential equation means what? By keeping all the variable to be constant, I will differentiate it with respect to y here. X is the another variable which is kept constant. So if I integrate it, I will be getting an integrating constant here, and that integrating constant may be a function of x also. I hope it is clear. Now similarly, how you will write this? I will take this minus and I will keep it here. So psi will be equal to minus vx plus some function of y plus some other integrating constant. Let me take it as c dash. I hope it is clear now. Why I am writing f of y? Because this is PDE with x variable. So y will be treated as a constant. So function of y will be treated as a constant. Okay, now listen. How to finalize my equation? Simple. Compare this two. This u into y is my f of y, and this minus v into x is my f of x, and these are some constants, some numbers. Okay, so finally my equation of stream function is going to be psi will be equal to uy minus vx plus some constant, we will take it as that constant as c1. Okay, and most of the cases c1 will be taken as 0. Okay, now this case, similar type of differential integration. If I integrate it, let me keep this minus here and let me keep this minus here. If I integrate it, phi will be equal to minus ux plus what I will get, function of, I'm partially differentiating with x, so here function of y plus some constant c, or I already taken c, so c double dash, let it be. And now this, if I integrate it, phi will be equal to minus v into y plus function of what? Here I am differentiating with y, integrating with y, so the function will be x plus c triple dash. Now finally, what will be my phi? F of x is minus ux, if I compare this equation. F of y is this minus vy, and constants will get added. So we'll get minus ux minus vy plus some constant, we will keep that constant as c2. Okay, so this is my final equation of a stream function and then and a velocity potential function. Now how to plot constant stream function line and a velocity equipotential line, we will see that. Okay, listen carefully. If psi is constant, c is constant. Okay, so if this is constant, this is constant. Let me take psi is equal to constant. Okay, already this is also constant, this is also constant. So how can I write? Some constant is equal to uy minus vx. Okay, and further modification, I can write it something like y is equal to v by u into x plus some constant by u. Am I right? What I'm doing, I'm just taking this vx to this side. Okay, this is in fact v. Okay, this is in fact v. Okay, I'm taking vx that side and I'm dividing with u. This looks similar to y is equal to mx plus c, where the slope is v by u. Okay, so clearly our constant potential function line will be similar to y is equal to mx plus c. Y is equal to mx plus c means how does the line looks? Which is like this. Okay, it will look something like this. I'm not drawing it properly, it has to be exact. Yeah, so this is psi 1, psi 2, psi 3, psi 4, psi 5. Okay, now what about this one? If phi is constant, okay, if phi is constant, okay, c2 is already constant, so I will get something like some constant is equal to minus ux minus vy, which implies minus ux minus vy, which implies I will take this side and see this side, so I will getting something like y is equal to minus u by v, okay, into x, some other constant, we will keep it as c double dash. Okay, so simply I am bringing this minus vy this side and some other constant this side, and I am dividing with v on both sides. Now check it again. This is similar to y is equal to mx plus c, where the slope is negative minus of u by v. Okay, minus of u by v. So negative slope. So my equipotential line will look in this direction. Again, it's a straight line, but negative slope. Okay, it's a negative slope. So again, it's a straight line but negative slope, and it's going to be perpendicular. Okay, so phi 1, phi 2, phi 3, phi 4. Okay, and we know that this represents direction of the fluid flow also as such here. Now if I want to convert these two into our general form, that is polar coordinate form, what I need to do, I'm not going to do it here, I'm just leaving it to yourself. Simply I will take some position vector p, some position vector p, and this is r. Okay, and the angle between this position vector and x-axis, okay, angle between position vector and x-axis is theta. So what happens, if I project it in x-axis, x will be equal to r cos theta and y will be equal to r sin theta. So substitute wherever x is there, substitute r cos theta. Wherever y is there, substitute r sin theta. I will get psi in terms of polar coordinate. Similarly, phi in terms of polar coordinate. Now understand the difference now. Understand the difference. This is v vector. U is what? U is v cos alpha, don't forget that, u, and v is, small v is v sin alpha. Okay, so alpha is the angle made by velocity with x-axis. Theta is the angle made by this position vector with x-axis. So finally, if I substitute everything here, how does it will look? Instead of u, let me just remove the constant c1. I'm not going to worry about the constant c1 and c2. So instead of u, I can substitute v cos alpha, and instead of y, I can substitute r sin theta. Yeah, r sin theta. And similarly, instead of v, I can substitute v sin alpha, and x I can substitute r cos theta. So minus v sin alpha r cos theta. So that's going to be equal to, I will take v and r commonly, so it becomes cos alpha sin theta minus sin alpha cos theta. So v into r into, what is this cos alpha sin theta minus sin alpha cos theta? That is sin a minus b formula. Okay, so I can write it like sin a minus b, so sin theta cos alpha, okay, to be in order. So sin theta minus alpha. So this is my psi. Okay, where theta is angle between position vector and x-axis. Alpha is angle between velocity and x-axis. Similarly, if you substitute x and y, I will get phi as v into r. So it is minus vr cos theta minus alpha. Okay, so this is in polar form, this is in Cartesian form. Please remember the things carefully. What is theta, what is alpha, all those things. Alpha is angle between velocity and x-axis, and theta is angle between position vector and x-axis. And how does the constant streamline and equipotential line looks? Streamline looks in the direction of flow only. Equipotential line looks perpendicular to the flow. Okay.